Let me stop sharing so we can do your introductions.
No
And
worries. You can still share. All right. So welcome everyone to SQL Friday number 130. This is the first time we're live streaming on YouTube. So if anyone is watching from YouTube, you're very welcome. You're not more welcome than others because everyone is welcome. But it's nice to see, and I would really like your comments, people on YouTube, if you can just comment on the quality of the show from there. Uh, with no further ado, welcome Armando Lacerda to SQL Friday, or welcome back. And you're going to talk about snapshot backups today, or as the title is, this is not your
yes.
your daddy's backup routine, which is misspelled. So I'm going to fix that. Uh, All right. So, with that said, the stage is yours.
Thank you very much. Appreciate it. See, here's my teams. Hello, everybody. Good morning here from California, United States. About 3 in the morning here, and my name is Armando Lacerda. I am a Microsoft MVP. Actually, let me get my slide deck up here. Let me share my screen again. There we go. All right, let me get this up. All right, can you see my slide deck? Perfect. So yes, my name is Armando Lacerda. Here you guys like my email address, lacerda at mvp.ms. I'm a Microsoft certified trainer and also Microsoft MVP on data platform. I work as independent consultant. I work with multiple consulting companies. Nowadays, I work with 2 of them, but over the years, I've been working with many consulting companies. And I've been working on the SQL platform for, since SQL Server 6.5. I've been collecting a lot of experience, a lot of fun stories. And talking about fun, I titled this session like this is your not your daddy's backup routine, just because I want to make some fun of it. Full disclosure, my dad never touched a computer in his life. He passed like 20 years ago, and his career, his profession was something else. So here's around who would be laughing with us about this. The idea here is like I used to do things one way, and I was taught to be doing things in one way, but there are new ways, there are new options, so it's not as it used to be. So during the presentation, to no, that's kind of trying to be bring some humor here. This session is about an hour long, so I have some demos here to go through with you. And as we are going through this exercises, we're going to have time for questions later. If the presentation Agnes will bring them up. Keep the conversation going after this session. You're welcome to connect with me on link. That's the code that's there is URL. So if you're on a cell phone or something, you can just beam that, and it would be great to keep the conversation. All right, so let me make sure my things are working. You know what? You can see my slide deck. I can't. So believe things are working. Teams are not showing it here for me. So not sure which slide is showing. I miss. That is a nope. How am I gonna do this?
So you can't
All right.
see the slide deck, you say?
Yeah, Teams is not showing. Let me see. Resume slideshow. Yeah, I can't see the slide deck on my end. All right, I'm gonna browse it here. Hopefully it will pop up. All right.
Yeah.
Okay, so let's talk about this backup idea. I'm hoping that it's titled Backup Basics and Goals, right? You see, what we're going to discuss here, what the things we're going to see on SQL Server 2022, they were actually first released about 8 years ago when SQL Server 2016 came along. And when we are talking about backup and restore, it's always a very important conversation. And companies, they are always sensitive to this topic because they want to make sure they don't lose any data. So companies, they usually support or they adopt two distinct strategies to make sure they don't lose the data that's in the database, that's in SQL, right, in their databases. One is called disaster recovery, and the other one is called high availability. So here in the slide, on the fourth line in there, we have backup, which is disaster recovery, right? Would be the idea of disaster recovery. And the other one is high availability. And they usually placed on distinct fields. I do high availability is one thing. I do backup and restore my disaster recovery. It's another strategy, is something else. That's how DAD is used to see these things. But if you look around, if you really pay close attention to this, and if you are available to us both on premise and in the cloud today, this line separating these two strategies, this line kind of blurs a little. So what's the main goal? The main goal is to recover, like the first line in there, right? It's to recover from a catastrophic event. And what is a catastrophic event? Oh, well, it depends, right? Maybe my computer burned up, the motherboard burned up, or the rack where my servers and the storage are, caught on fire or something. A long time ago, when I was down there in Brazil, I'm originally from Brazil. There was this factory in Rio where I used to live, and the factory caught up on fire. The whole thing started caught up on fire. They used to do underwear clothes, and those things are really flammable. And there was the factory, and there was a building attached to the factory, which was the administration building. So the factory started catching on fire, and everybody was evacuating the building. And the manager got into the building against the flow to go into the data room and start picking up all the hard drives he could and the and the backup tapes he could to take out of the building. And he was kind of the hero thing. It is a true story, right? He got up the hero thing to save the company's data because the whole thing was going to get to be burned out. So that's the idea of catastrophic events. Before moving to California, where we have earthquakes every single day, multiple of them, but they are usually very small. We don't really very weak, right? We don't really feel them. But before moving here, I used to live in Florida, and in Florida there is this hurricane season. And during the hurricane season, we usually have hurricanes. They may be big, they may be small, but the backup strategy there was that one where we had the backup downloaded to a tape, right? We back up to a tape, and we make 3 copies of that tape. We keep one in the building. We keep one in a few miles away, like 100 miles away, and we send another one out of state because hurricanes, they tend to be big, so they could catch to the other city where we send the tape to. So just in case, we send another one to another state. We used to send it to Atlanta, Georgia, and if something happens in the building, we'll brought that tape from there. For my time when I was working over there, I never needed to do that. We never used that tape there in Georgia to restore anything, but we have used the local tape multiple times. So that's the idea, right, of a catastrophic event. You have to rebuild from scratch, and you have to bring your tape, and you have to restore everything and start building up from ground up. And when you do this, there are two main elements you have to design, right? You have to try to predict. And as a matter of fact, you need to have them documented, which is the RTO and the RPO. You may be familiar with this, but just to make sure we are all on the same page about these two concepts, right? The RTO is the restore objective, right? How the time to get the system operational. So how long will it take to bring my system back up? We're talking about the restore, right? So I have to start from scratch. I have to build the server up again and then download my database or restore my database, get the database up and running. So how long does that take? 1 day, 2 days, 3 days? Because that is how long the business will be um, not operational, right? Because if the business depends on the computer system, on the database, the business will be idle, right? Will be in pause waiting for this. And I had a situation like that, not in SQL. Before my time in SQL Server, I was working with this other database. This was back in mid 90s for Unix environment. There was this database on this insurance company I used to work for, and on this database, they ran on this DEC, Digital Equipment Corporation, is a company that's long being acquired by Dell, and the hard drive failed. And down there in Brazil back then, those hard drives were not available. So we have to wait for a hard drive to come from US to Brazil so we could replace those hard drives. So it took 2 days for the hard drive to get to Brazil. And here's the point here. After the hard drive was there, it was an insurance company, so it's all about data, right? You need the system, you need the database to get the insurance policies fed into the database. And as a hard drive arrived, the director was like, okay, so we are operational now. And I was like, nope, there's this backup strategy here. We do a full backup once a month, and we do differential backups every week. And we do transactional backups, would be the equivalent for transactional backups multiple times a day during the day. So we have to follow the restore operation. And we used to use this very popular tapes back then called kick tapes, and those things were slow, man. It took 3 more days to restore the database on that system. And my director, he was mad. I remember once he took, he would stand up on a chair and it was like, my company's not working but it's not been working for 4 days. You're killing me. And I was like, sorry, I didn't implement this. I've been here for a month only. I was a new hire there. But that is the RTO thing, right? It's how long it will take to get the system back operational. And you have to measure this. You really only know this when you get an environment on a site and you restore the thing from ground up, right? That you really know how that goes. And the other one, the RPO, is how much data you will lose when you restore your database. Like I said, that backup strategy there was doing transaction logs multiple times a day. I can't really remember how often it was. Let's say it was every 3 hours. So if my database, if something happened to my database and it got corrupted, or any kind of a catastrophic failure, I will be in jeopardy of those 3 hours, right? If I was close to the transaction log backup, I would be losing like 10 minutes, 15 minutes. But if I was close to the next log, I could be losing close to 3 hours worth of data, which means people would have to, feed the data back into the system. So you need to have these two measures, right? It's to any backup strategy. Now, what is not there, but will show up in the next slide, is a very important factor. And the factor here is usually overlooked when people design backup strategies. And that's when SQL 2022 will bring a very interesting feature for that. It was, like I said, it was first introduced in 2016. But back to the discussion of backup and high availability. The factor is going to show up on the next slide, but the factor that's missing here is how big is your database? Because when we both start as a DBA, taking care of databases, we've been taught, right? You have to take backups of your database. So how do I take backup of my database? Full backup, differential backup, transaction log backups. There are other options, which I'll be talking about them, but there are other options. But usually people don't look much in those options because these are the most popular ones. So it's like, this should fit, right? I should work on this one here. And if your database, it's a small database, it will definitely work, right? Considering the RTO and the RPO, it will definitely work. But again, what's going to be the downtime to get it back? You know, if there is a single point of failure, how often you're going to do this? Like if your database is running out of one disk, how often you have to restore the database because the disk keeps failing, right? Or something like that. Um, so this high availability start when it was first designed. The idea of high availability is preventing you from having to restore if there was a failure. So now it's not more a catastrophic failure, it's just a failure. So if I have one hard drives, they fail all the time. Unfortunately, they do fail quite often, especially in production environments, high demand production environments. So what about if I have multiple drives? Used to be referred to as hard drives because they were spinning disks, right? Now they are SSDs. So let's call this storage place. So I have multiple storage places, and if one of them fail, I want to have a copy of that data in the other one, so the other ones could keep the system working. So the original idea was like, let's not do the restore. Let's try to keep the system going, running, even if there was a hardware failure. So let's avoid a single point of failure. And that was the idea with the hard drive. And then it came with support to multiple servers. And then SQL Server availability groups, which is in a way, right, to do the same thing, but based on SQL technology, not on hardware technology. So SQL Server implemented the availability groups, or distributed availability groups, or DAGs for short. And SQL Server does the replication of data, and then you would have very inexpensive, instead of having a cluster, right, a server cluster based on Windows operating system, you would have just SQL Server running. Either Windows SQL Server will be communicating to other SQL servers and send the data that was flowing through the transactional log to the other servers. And therefore, you would have what I call there on the slide deck, the last green line there, I call it the data block replication. And there are options to this. But here, none of this is actually considered a backup strategy because I'm not dumping my database someplace and be able to restore that database from that place, right? Offline place. I'm actually getting my data copied to other servers that are actually online, and hoping that if there is a hardware failure, I don't have to do the restore. I just run from the other server while I put my system back up. The bottom line here is disaster recovery and high availability. They have traditionally been considered different strategies, but depending on the size of your database, they could mingle, right? There is a line. There is, like, unlike my daddy's used to do, where they're like, instead of doing backups, we just replicate the data, because at the end of the day, a backup is a copy of my data. It's a type of a replication of my data. So that's food for thought. I'm gonna keep going on that one in there as we progress. And of course, there is always the budget factor. How much that's going to cost to the company, and the company will always balance it if you're going to invest on high availability hardware or invest on more SQL Server license. Because if you're doing availability group license for the other servers, depending on license contract, you may need one license, the other one will be on standby, you don't need a second license. But if you are using read-only operations in there, then you need a license. So it gets into the budget side of which I'm not gonna get into. because licensing it's a dark magic inside SQL Server. I don't like talking about my about license. All right, so let's move on. All right. When I first presented this topic, when SQL Server 2016 came along, my first is of course updated to SQL Server 2022, but I'm kind of a melancholic guy. I kept the same, designing there. I do different designs nowadays, but I kept the same design just to remember that story because when SQL Server started doing backups in a different way in the cloud back in 2016, I presented that in kind of the same title. Actually, the title was more provocative. It was a SQL Saturday in Chicago, and I was like, why are you keeping doing backups in the same way? And the room was full. I had like 50 people in the room. And then when I start showing how the process works, the a little fight start breaking up inside the room. People are like, this is not really backup, doesn't work like this. You have to have a copy somewhere else. And I kind of froze this presentation here for a couple of years, and I brought it up last year when SQL Server 2022 came along with this new support. I said, okay, let's bring that topic back up because I think the world is better prepared for this right now. So let's make sure we are on the same page here. What is the idea of a backup? A backup is a copy of the data, and I hope this slide here is shown fully there. So it's a copy of the data. It's animated, and I'm kind of having a little of a hard time here to see what's being presented to you because it doesn't show in Teams. But I think I have two lines in there, right, Magnus? Backup of the data and without affecting production, right?
It says backup premises a copy of the data and then a comma.
All right. And then now without affecting production.
Yes.
Perfect. So that's what we're trying to do, right? We want to create a copy of the data and we don't want to affect production. Now, keep in mind, as I'm doing backup, I don't want a production to stop, right? Data must be kept being inserted or updated. Transaction must be supported in the database. That's going to be a big deal on the things we're going to show in the field. So keep that in mind. I want to create a copy of my data without affecting production, done in a different media. So I have the original destination where it goes, and I want a copy on a different media. That's a very important concept. And that media must be kept somewhere else. So that's the general idea of backups. Now, this is going to change. And that I'm doing the disclaimer here beforehand because I don't want anybody going to stop YouTube with the complaints about this is not really a backup. This is going to change. And again, the main drive for the change is the database size. See, right? The main drive for this thing here is the database size. I believe it's showing there. And why is that? Well, I didn't mention during my introduction that currently my field is on data engineering, data architecting, data engineering for the cloud, where I work with very large databases. I mean, like I told you, for that insurance company, it was an operational database, and I used to work full time as a DBA during many years, right? I'm still a proud DBA guy. People talk to me, I'm a DBA. When this data engineering came around, I was like, what's data engineering? Are they going to kill DBAs and do data engineering? In other sessions, I like to comment on that one. Like, data engineer is the SSIS guy that does code, right? You do Python code, you do some kind of code instead of doing drag and drop. And if you do Microsoft, you can use ADF in the cloud and use some drag and drop there as well. But I'm a proud DBA. I've been doing DBA work for a very, very long time. And what I've noticed is as the database size grows, it's when the backup strategies start becoming complicated. And to a point, it may become just not doable. right? You cannot do it. On the databases I work with, for data engineering, do some machine learning, I get databases with the size of 50, 60, 70 terabytes all the time. I have multiple clients with, multiple hundreds of terabytes of data. Once I got a project, it was not one database, it was a collection of databases, but the entirety of the data there, it was 8 petabytes with a P, like Peter, right? It was 8 petabytes. Now, how do you back up 8 petabytes and control the RPO and the RTO in the fashion that the company wants to do it? So the size of the database is what is the main factor here to change the backup strategy. And once again, if your database is 1 gigabyte, 2 gigabytes, 100 gigabytes, it may not be a problem for you. The RTO and the RPO are okay. So you don't have to change your strategy. What are we going to do? What I'm discussing in here is different backup strategies when you get a database that's like takes 5 hours to restore, 10 hours to restore. For most companies, being offline for 10 hours after you have rebuilt the system may take too long. It's just not what they can support, right? So when you get to those points, you need a different backup strategy. So before we Microsoft released to us what we have today, their first approach was this one here. You may be familiar with this. We know that a SQL database, right, a logical SQL database is comprised by data files, and those data files can be organized into file groups, right? You can create a file group, multiple file groups, and group your files into those file groups. From the application standpoint, and also for performance tuning, you can have those file groups like operational data that's being currently used could be in one file group with high-speed disks, while historical data could be in other file groups with less expensive disks, and of course it's lower disks, but they are not queried as often as the current period of whatever time the company decides to be. So we can define these file groups here, and the file groups can be used both for performance tuning, like I just mentioned, and also for backup strategy. Like if this database that I have on the slide deck right now, and I believe I have a picture there that's like a database with, if it's not, Megan is gonna let me know. And I have
That
three,
is,
six, seven,
that's what we see, yes.
eight disks in there. So, if file group 3 is historical data that more likely is not going to change, I don't have to back up that often, right? And there is no changing there. So I take a backup once and leave it there. And if file group 2 is also historical data, but could be under auditing and may have some changes in there, I would back up it when needed, right? While file group 1 would be my real operational data that's changing every day with the operation. So my file group 1 would be into my backup routine, right? My regular backup routine. And if this database is like 100 terabytes, and let's say 90 terabytes are file groups 2 and 3, and just 10 terabytes are file group 1, a regular backup strategy could work in here with a reasonable RTO for the company, right? And RPO as well. Reasonable benchmarks there for the company. And then my backup strategy would be backing up just file group 1, while file group 2 and 3 would be backed up only when needed if something changed in there. I hope that makes sense, right? You may have seen this before. It's not that popular because most companies I see out there, they don't have that much data in there. But if you do, you can do this, right? You can even go to the data file, back up the data, just the master database, or just the secondary database there on file group 1 on the green box there. So you can go even down to the data file. Now, if it comes to restore, if the disk supporting the secondary data file on file group 1 fails, I can restore just that file, and the transactions log that came out of that file. So my time to operation, my RTO, could be, just that disk, not the entire thing. So that will accomplish the task, right? Will be the RTO will be smaller, and hopefully all my tapes or whatever, but I keep my files, they're all available online and up to speed. And this is a very traditional one. That's how my dad used to do for very large databases. But still, you are relying on building up. I have to get a new disk, put the disk in there, and restore the database in there. Restore the file in that case, right? Restore the file or files, depending on. So your RTO here will depend. I have, I believe it's showing the resource monitor screenshot in here.
Yep.
What I have in here is, the time to restore will always depend on what is your throughput on the hardware supporting that that data file. In this one here, I took a screenshot when I was running on a NVMe somewhere. So I was doing the lab in there. I was gonna take a screenshot of this one here just to show. I got 1.5, almost 1.5 gigabytes per second throughput going for just not bad, right? It's kind of reasonable. And depending on the size of your files, that will help you out. This is going to be your main element to show or to help you predict what's going to be your RTO. Let me get my mouse here just quick. Let me get something up and running that I just came to me that I forgot. Photo.azure.com. Oops. Because I'm approaching my demo time at azure.com. Let me make sure here I have the virtual machine available for us. 1 second. My virtual machine is here. There it is. Oh yeah, look at that. All right, so the virtual machine is coming up. When it's up online, I will put that on the screen. So back in here, let me see. Here, yeah. So your IO, right, is the one is gonna determine that. Now, if you are working with SQL Server on premise, this is your storage, right? You have your switch, your network that's dedicated to your switch. So jumbo packages, all of these things, all the hardware tuning that's necessary to accomplish the best IO you can have. On the other hand, if you are in a cloud, what you got to look at is what is going to be your I/O to the device that you are connected to, and that's usually dependent on the type of virtual machine you are running in the cloud. So if your virtual machine is a low profile, and that's funny enough, right? That is tied up to the amount of CPUs you get to the virtual machine. So if you get like 4 CPUs, you have is lower disks to talk to. And the ratio, I asked that from Microsoft people one day. I say, why is that? I have to get a very beefy VM that I don't need that many CPUs, but I need the IOs. So why do I have to get that VM in order to get the IOs? And the answer they gave me is around those lines. We have to keep a balance of the IO in a rack and the cores that I have, the servers that I have in a rack. So if you get 4 cores, but I give you the entire IO that I have in a rack, everybody else is going to be penalized. Mm-hmm. So I have to balance. I have to ratio all of them to they gave me. So I'm paying premium premium price for IO based on the vCores that I really don't need the vCores. I just need the IO. So I find myself sometimes, not that often, but I find myself sometimes getting a VM with like 64 cores just to get the database restored super quick, and then I shrink it down to 8, 10 cores after the database, so I can get those kinds of IOs when you go into the cloud. And in particular, I'm talking about Azure, right? Not AWS. AWS is a different picture. So that's what you're dependent on. You're really dependent on the um, I/O supporting your data files. All right.
And if I may add, I mean,
Sure.
people may think that, okay, so then the VM is going to be more expensive, but since we're talking about running SQL Server in the VM, the licensing is like the big issue. If you need to add 8 CPU cores, well, then you need 8 more licenses, and just to get the I/O throughput that you expect. So it gets expensive quickly if you need really good I/O.
Exactly. I mean, you can. Microsoft's not going to put the FBI on you if you get your course to like 64, like I said. You restore your database and then you bet it down to whatever license you have. They will not really penalize you on that one, but don't quote on me, right? That's no liability on me. It's kind of a it's just let's be good neighbors. It's kind of the idea. Keep it running like that. The license, like you said, it is a problem because it becomes expensive on the VM side and on the SQL license side. Perfect. Yeah, that's a great point. All right. Let me see here. I'm bringing up the virtual machine, and of course, the virtual machine is giving me a hard time. So give me 1 second. Let me make sure that this thing comes up in
The devil is in
MSTSC.
the demo, right?
Yes, for the demo. Let me do the display thinking here. There we go. This should do it. Connect. Um, okay. Oh, there we go. Now let's get this guy here. And let me see here how this looks like. Let me get this like this. Okay.
Looks
All
good.
right. Now it's just for me to see what's showing up on the screen. I'll be back on the way I was in a second. Let me go back to the slide deck. You here, you here, and the virtual machine just came up. So you know how these things goes, right? It takes a while for it to open up. So let me warm it up here just quick. There it is. Bang. Okay. So while this thing is coming up, let's go back to the slide deck. There we go. And dang, perfect. So let me change my screen here back to what it was. Like this. There we go.
Awesome.
And my PowerPoint. This has been fun, I'm kind of like, wobbling here in between slides. Okay. Um, so then, so that's the story, right? Now, from this slide on is where things start to change. And again, it was a bit distracting to me trying to get the VM up in there. So let me get you back on track. All the backup strategies, differential, full backup, differential logs, they're okay if the database is up to a point in size, and that point in size is not really a number of the size of the database, like 1 TB or 2 TB. It's actually dependent on your throughput, because your throughput will define your RTO when restoring the database, right? It's going to be the main factor in there. So, but there will be a limit to that. At some point, there will be a limit. And if you are working with very large databases, that limit, you're going to reach that limit, and restoring in a short period of time will be a challenge, will be difficult. So back in 2016, when MySQL Server 2016, they brought up this feature called the file snapshot backup. That is the one you have on your on the screen right now. So the file snapshot backup it's a feature. It's still there in SQL Server. It only works in the cloud. So don't try this on premise. It's not gonna work. It only works in the cloud, and it only works in the cloud in Azure Cloud on a particular case, right? You have to build your database the way I'm showing on the slide deck. So how does it go? You have SQL Server running. More likely, you're gonna have SQL Server running on the VM that's in the cloud in Azure. I'm a crazy guy, so don't follow me here, right? But I tested this on a VM running on premise and the data files in Azure just to see if that would work. And it did, but it becomes expensive and very slow. So don't do it, right? The VM is supposed to be in the cloud. So you got a SQL VM running in the cloud. And when you build up a VM, right? When you create a VM, the VM will have virtual hard drives. And if you go into the Azure portal and you ask to create a VM, the VM will come with some. And if you use the default template they have there, it will come with like I think 3 data disks for that VM specifically for SQL Server files, because we are into that idea, right? We can get, if I need store, I add a managed disk into my VM and put my data file on that managed disk. Some people use NVMEs for that to get more speed, but they forget that NVMEs are ephemeral. If the VM reboots, you're done, right? If the VM stops and restarts, you're done. You lost all your data. So be careful with that. So in 2016, Microsoft came with this idea. Instead of creating your data files on a hard drive, on a virtual hard drive inside your VM, you should create for large databases, you should try creating or consider it, that's the word I was looking for. You should consider creating your data files and storing your data files on a storage account outside the VM. So you can go and do create database, my database name, file group, primary file group or whatever file group you're doing, and have file to URL and pointing to that URL. This is fully documented, right? Public documented. You can take a look in that. Now the thing is, when you do a storage account, there for per file you have in a storage account, you have a throttling speed. Depending on the type of storage account you have, it will be higher or lower. It can be up to, the total sum of it can be up to 60 gigabytes per second, which is pretty good. But per file, it's way slower. So the idea is to spread it out through multiple data files. And I have it there on the slide, like 200 gigabytes, kind of a magic number that you see all around when you are working with these things. That's nothing official. But they say, like, if you keep your data files around 200 gigabytes, 300 gigabytes, kind of a magic number for good data placement. But these things change. So, it's just a suggested number in there. And your throughput for your database will be the collective sum of each one of these data files. And if you're keeping multiple storage accounts, there is no extra cost to have. You also get more performance for your transactions going on in and out. To get more I/O, right? More throughput. Now, to the backup topic we are focusing on here, here's the deal. This was the file snapshot backup. And here, a quick pause. When we say file snapshot, that word snapshot is very overloaded. When we say snapshot, people are like, which snapshot is this guy talking about? So there is a SQL feature that has a similar name called snapshot databases, which has nothing to do with this, right? It's a very interesting feature. You should look into this, not for backup and restore strategy, but something to support developers and this things. It's a great feature that's there in SQL Server for a very long time. But this one here is about the backup strategy. And the idea of the backup and the idea here is it works only on this scenario, on when your data files are in a storage account in SQL Server in Azure. So if your SQL data files are in a storage account in Azure, you can issues a particular SQL statement that came in there that will not make a copy of those files. It will freeze those files in the storage account. We'll have a control file behind the scenes, metadata, recording the metadata about that. And new files that you would not see will be available in there with the new transactions from that point on. So that's the idea of the snapshot. You freeze what is in there, you start creating from that point on, kind of a differential kind of a approach. And SQL, nothing changes in SQL. It's really transparent to you. So you do have multiple copies of your data, and if your is zone redundant, you have those data in multiple distinct regions to that backup definition we had before. But there is no data movement at the time of backup. It's just a freeze on a collection of files and files with the new transactions. And if you want to restore, you can restore this thing at any point. And the beauty of the restoration of this is when you restore, you just restore a differentiation of it. There is no data movement. There is just a point to a particular LSN, the log sequence number on the data files, and a new collection of data files for the new database. We start from there. So what happens in here is if I decide to restore this thing, the restore time will be amazingly fast because there is no restore. It's cheating. It's just creating differentials starting from a particular LSN that you point to. So the statement to, come on. Oh boy, it doesn't. Something is happening here. Let's see what's up. Down here. Move. There we go. So the command to do the backup is this one here. You see, is a backup data. This is from SQL Server 2016. Backup database to URL. You point there, whatever URL you want to do. And that is the, where's my mouse? Here's my mouse. That's the key element, right? With file snapshots. So this thing here, when you do this file snapshot, is when it does all those things I just explained. And again, the backup happens like this. It's like minutes. And when you restore, I would have a demo there for that one, but let's go to the other one. When you restore, very little I/O is actually consumed. And if you can see in there, see the backup of a few terabytes database was done in 57 seconds. And this thing in here, this demo is on this URL. And again, the QR code here points to this URL. So Microsoft, this is Microsoft. I mean, Microsoft recorded that one. If you want to, get that QR code there or get the URL here behind me, and check it out later, you can see the recording there. So this is the kind of RTO I like. 10 terabytes of data in 57 seconds. Man, I gotta raise. That's what I want to have. But the problem here is this in Azure. If your data file is in Azure, what if my data file is in on-premise? If I want, I don't do cloud. My thing is not in the cloud. My elements are actually in on-premise. So this is the new thing that Daddy didn't get to see. This is the new thing that in SQL Server 2022, they brought this approach to on-premise. We can do the exactly same thing with on-premise. And the way it happens is like this. Let me get here, make sure that these things are working. The way it happens is this. There we go. This is not the way it happens, by the way, just to give you a background on this. There is a subsystem side Windows called the shadow copy, right? Windows VSS. And this thing is dangerous. Now look at me, I'm gonna get really close to the camera. This thing is dangerous. Don't do it. It is supported. There is documentation on how to get snapshot backup, file snapshot backups on Windows servers, and running SQL Server doing this. But this is not what I'm telling you to do, because this is prone to corruption. I have seen people crying very sad, very sadly, because they adopt this. It was super fast, but at some point, some mess up stuff happening there, and they lost their backups, and they were unable to restore the databases. So really sad stories, right? Don't do this. This is there on the slide, old style. What you will do, this is still the old style, sorry. What you will do is this, the transact SQL snapshot backup. So while the file snapshot backup was SQL Server 2016 name for the feature, this is the name for SQL Server 2022 on-premise transaction snapshot backup. And I brought the old style here. I'm going to go back one slide. I brought the old style here to for you to understand this. SQL Server is working. There is a process of SQL Server to write to the data files, and that would be talking to VSS to cache those operations in there while the hardware has been backed up somewhere else. Now, the problem here is the operating system is working with the hardware to do the shadowing thing. This is what changed. SQL Server will not rely on the operating system anymore, because for most on-premise systems, the actual storage is not on the server. It's on a remote storage someplace, right? You use Pure Storage, you use, whatever, Dell, EMC, whatever you do, right? It's on a separated one. So SQL Server is like, okay, let's not use Windows, because SQL Server runs on Linux as well. So let's not rely on Windows only. Let's use the hardware provider to do this. So what happens then is we're going to tell SQL Server, pause transactions. So I can go to the storage and say, snapshot the files on the storage way, whatever way the snapshot, the hardware does that, the storage does that. And that's supposed to be like seconds operation on the storage side. And when it's done, I go to SQL Server, okay, I have a snapshot, save the metadata, and keep the database going. This is how it works. What I need to emphasize here for you is when you start this, when you suspend the database, transactions are suspended. If you have an insert going into SQL, into the database, that will be on lock. It will not fail, but will be on lock. So from the time you suspend until you finish your the snapshot operation, whenever it's done, all transactions are on hold. They are blocked, right? They are behind a database lock, and that database lock is enforced. When you do that, all the transactions that are going, they go through. Every new transaction pile up until it comes back in. So that breaks that idea of a backup. Backup operations should not disturb production, but this one will. But again, if you are dealing with very large databases, like I do, many people do, it's something you may balance, because if the storage provider is able to do the snapshot in a second's time, it may be like just a bump, right? There's something on the internet. It may be just a bump going on. Whatever it is, make sure you understand that there will be a period where transactions will not fail, but will be on hold, will be on lock. Not a deadlock, but hopefully, but it will be on lock. And this is the idea, right? This diagram here, it's actually from the documentation. So what you're doing here, and I'm gonna go back here to be smaller again so I can see my screen. Where my screen showing? Let me see here just quick. Let me get to this. No, this one here, this one. Yeah. Here's my mouse. And let me see if I can. There we go. So this is how it goes, right? Um, here. This is the statement we issue first, right? I want to alter the database state, and I want to set it to suspend for snapshot backup. We send this statement to SQL. And again, this is for on-premise, right? This is for SQL servers running on-premise. It's not nothing to do with the cloud. For SQL Server running on-premise. When I do this, it's when my transactions start being blocked and piled up. And then I go, and then I go to the hardware provider and ask the hardware provider to run the snapshot procedure it does. So it's a two-folded thing. You see, I had to go to SQL and say, SQL, we're gonna do a snapshot backup. And I go to the provider and say, do the file snapshots. So to the provider, it's just a file snapshot. Doesn't matter what kind of file it is. But this freeze guarantees that there will be no corruption, right? No desynchronization of log and data files. If the snapshot ran okay at the hardware provider, I go back to SQL and say, hey, save the metadata. So if I need to restore this, you know where to restore from. Save my metadata. This is it. When you do this, the freeze of the database goes away. The block goes away, and all the transactions are flushed back into the database. So everything comes back to normal. This should not take more than 30 seconds, depending on your hardware provider, right? They should not take more than 30 seconds. So it all depends on how the storage account works. If it failed, if it failed, we do this, right? Okay, I tried to do a snapshot. The snapshot didn't work, so unfreeze the database or defrost, unfreeze the database, let the transaction keep flowing. I will work with the storage place, and then I try another backup later, right? So it's this simple. Statement-wise, is this simple. There is no big deal about it, right? What the coordination that happens here is the big deal, right? So this is how it goes. Clicking here. Here's an example of the same idea, right? Another example here when I want to restore. So we want my my snapshot, whatever needs to be mounted at the storage place. And then I go into SQL Server and say, you know what? I want to restore from my snapshot element, right? If I need to do transaction log restore, I go with the transactions log. Otherwise, I just point to the backup location. The bottom line is, with that statement, I will have my database restored. Of course, working partnership with the hardware provider in seconds, like we have seen in the cloud. And I have seen some storage providers demonstrating on this one here, and they achieve that, under a minute restoration of the files there, as we're able to do in the cloud. I'm gonna send this slide deck to Magnus later, and I have links here, not just from SQL documentation, but also to other providers. And there is a script, one of them, like this one here, on the Red Hat documentation, where if you have a machine laying around, you want to test this out, you can have a Red Hat storage simulator going on, and you create your data files in there, and you can do your snapshot from the Red Hat, simulating like a generic storage that will be somewhere else, so you can try that out yourself, right? So this will be your recipe in there. For the demo that I have the virtual machine come back up in here, there we go. The demo is kind of a anti-climate because the demo is super simple, right? The statements are super simple. So if I go, this is Stack Overflow database. It has, this one here has, I think it's less than 1 terabyte, half terabyte or something. But if I just get here a new query and I follow, get my mouse here away just quick, and I follow those scripts I just showed you. And this will be the end of it, right? I'm gonna end up my the session here just to show you the statements that are, of course, it's running SQL. So let me get this bigger here so everybody can read. Um, let's yeah, use master, go and alter database stack overflow, set suspend for snapshot backup equals to on. So you see, I got the message in here. Where's my mouse? Mouse. My mouse disappeared. Oh, there it is. I hope. There it is.
Yep.
All right. So here, right, the acquires suspended locks, right, in session 68. So there was no concurrent thing going on in there. So I got a suspended lock. Everything is fine. In terms of database, if I go to that database again, let's see here, a new query. And if I try to change something on any table there, let's see here. Let's bring a table here. This is tag. So select star from GBO tag. And if I run this, I see tags in there. Perfect. See the database, I can still query the database. But if I do like begin transaction and update DBO tags, set what? Count equals to 0 to everybody at 5. My transaction doesn't complete. Why it does not complete? Because the database is in suspended mode on the other session, right? It's not failing. It just doesn't complete. It's in lock, right? If I look into the system logs, it will be there. So now would be time for me to go. I should have done that already, right? To the storage place, whatever the storage place is. Use their statements, their supporting statements to create the snapshot of the file. And when the snapshot is created, I can come back to SQL and ask SQL Server to save the metadata. So backup database, Stack Overflow to disk. And here I'm gonna do D. Let me see here. What if I have the folders? If the folder is still there, drive D. It's kind of small. I have no idea. I have to wumble here a lot. TempDB. So let's save it here on TempDB just for fun. All right. Back in here. D TempDB and my snapshot backup. Lost my mouse again. There we go. My snapshot backup. There you are. Sorry for the thinking here. I need to rehearse this better next time I present on this so don't get that lost. So is that, yeah, with metadata, metadata only, and of course, get the new file there for me, format. So this should do it. See, yeah. So from the SQL Server side, that's how fast the thing goes. All right, I trust that the storage has done it right. I'm not checking anything, and I'm just saving the metadata in there. So metadata is saved, and at the moment I do this, the lock of the database goes away, and the transaction goes through. You see? So at the moment I save the metadata, everything goes back to normal. So as quick you can do that thing, the storage side of things is how quick your database goes back to normal, right? And story, and that's the story. Now to restore this one here, I'm not running the Linux thing, right? This thing is actually on data files, regular data files on a VM. If I want to do that on a VM, I can do some AZVM snapshot disks that are supported on Azure, but I didn't want to do anything that's Azure dependent. I just want to show you what is SQL, specifically to SQL. And so to do the restore will be like the same statement we have discussed before, all right? In summary, to wrap it up and open for questions, if there are any questions there, hopefully there are, because I'm a trainer, like I said, and trainers we are. If you want to feed us, you give us questions because questions is what keeps us doing these things. But yeah, that's pretty much what I had for today. And this is the feature in SQL Server 2022. And these are the links that you can use to try this thing on your own if you like to. And again, these are something you may want to try out and consider implementing in your production environment if you have very large databases, right? If your database is like 1 GB, 2 GB, 100 GB, your time to do the backup and restore may be very reasonable, so you don't have to worry about this, right? This is something that is really intended for RTOs that are above the watermark, whatever it is that the company doesn't want to go cross, right? Doesn't want to cross. So with that, Magnus, tell me, are questions? Are there any questions?
There were questions, and then you answered them before I asked them. So one was about what happens to the transactions while you freeze. So, and you just showed it. So
Yeah, they're locked. Mhm.
it's the definition of an excellent question is something that you're about to tell the listener in just a few seconds. A good question is one that you don't know the answer to. An excellent question is one that you intend to demo soon.
Yep, 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 yep. So that was an
No, I
excellent
think
question.
it was clear and good. So I'm and I played a little bit with this when it was new, but I really need to set it up for, you know, no backup is good if you haven't tested to restore it,
Yep,
and just the idea to try restoring it to another machine and so on in a real disaster scenario. I mean, since it's new to me, it's something that I don't want to rely on without properly testing and see that not only
smart.
the
That's smart.
technology works, but I need to know how to do the restore if I need to, because I mean that's my only job as a DBA is to make sure we don't lose data, basically.
Now, you brought up a good point, and actually going to make a note in here. I'm going to add that one to my presentation next time I present this. So that's a good thing about these presentations, right? We always tweak. Next time is different. There's something new. You made a very good point in there. The demo that I just showed, the restore would be done to the same VM, right? Because the VM is seeing the disks. The disks are mapped to that VM. And you
Mm,
just mentioned, I need to restore that database. I need to test. Very good point that you made. I need to test these things, and I need to restore the database to a different VM, not to the
yeah.
same VM, because potentially it was a catastrophic failure, like we discussed, and I'm building a new VM from ground up. So I
Mm,
need to get that on a new VM. So I will get that. I have already noted in here. I will get a demo on that one so we can restore on a new VM.
mm,
So
mm.
good idea. Thank you. And to that
So,
point, to be able to restore to a new VM, the VM needs to map the same way the old VM or the factory VM mapped the LUNs on the storage place, right? It has to be the same mounting mapping. The mount
yeah.
must be exactly the same. That's the key thinking there.
Yeah, so I mean, if I get a corrupted database, I can pretty much on my own take care of restoring it to if I just have a server.
Yeah.
using this technology, I probably need the storage team to help me as well. I mean, and that's not a problem in itself, but it makes the organization a bit bigger around disaster recovery, because it's not like DBAs take care of restoring databases. It will be DBAs together with the storage team to make sure then the VM can get that disk mount going.
Yeah, good point. And again, always look into the documentation of the storage provider. The ones I have seen, it's a single PowerShell statement. So yeah,
Okay.
take a look.
Mm. Yeah, and I talked to, I think, Andrew Prusky about, he's working for Pure Storage,
Mm-hmm.
uh, and and when they tested this like on huge databases first time, it's like, no, this can't be true. It can't be that fast, and then it is. It's like, so it's a game changer once you can trust the processes around it. It's like, I mean, for me, some of the databases I worked with, we never backed up the whole database. We had like partitioning on tables, and we had read-only file groups that we only backed up once. And it's a bit scary because you back it up once and you store it somewhere. Is that somewhere going to be readable when you need it? So I mean, this in itself is a game changer, because you can actually take a full backup in.
It is scary when you restore and the restore is under a second and like what?
Yeah. But I mean, it makes sense too, because the restore is
Under a
just
minute already, say
actually
sorry.
pointing to, okay, these are the files. So it's
Mm-hmm.
more like attaching the database than doing an actual restore.
Yep. All right. Any more questions there?
Nothing in the chat here. No chat. Nothing in the chat on YouTube. YouTube was mostly video and audio quality. It wasn't perfect in the beginning, but it became better. So I think we made a good. I mean, for me, it's a demo as well to try to live stream to YouTube. I've never done it before, so.
I hope it worked.
So I'm sorry if you became the guinea pig of that
It's all
experiment.
good. I don't mind. I love it. I love experiments.
It's the way we learn, right?
Yep. All right. So that's it for the day. Thank you again, Magnus, for having me on SQL Friday. It's always good to get in touch with my friends on the other side of the pond.
Are you going back to bed now?
Nah, too early. I mean, too late. It's 4
Okay.
13 already. I'm gonna start my day early and finish it early.
Okay. Yeah, just get coffee and you'll be good.
Off it is.
Yeah. I if you noticed I ran away for half a minute, it's because I needed to fill this.
Yeah, I saw you come back with your cup. Yep. We all need it.
True. Armando, have a fantastic weekend, and I'll see you next time we see each other.
Thank you. Thank you for